Start out this build by installing the motor. Secure the motor to the motor plate, then heat it up with either a hot air tool, a hair dryer, or a lighter like I'm using here. Be careful not to let it catch fire. When the part is hot, it'll become malleable. Then simply grab it with a pair of pliers about a 1/4 inch down, and then fold it up and let it cure. You're going to make a U-bracket here so it is secured to the fuselage. Heat up the other side, fold it up, and then this will be secured to this fuselage to make the motor mount. The motor mount is simply glued in place. Nothing fancy here. I'm using hot glue, but welder, goop, or other similar adhesive work. Be sure to maintain the thrust angle. It should thrust down towards the nose. The wings of the airplane are simply glued together. There is no spar you have to put in the wings. That spar is actually for the fuselage and will be installed in the next step. You'll want to be sure the wings line up properly. Any adverse twist could cause the plane to roll. The spars are embedded in the fuselage from the tip all the way to the tail. I'm making a straight line on either side of the tail here, so I know where to cut along the fuselage to fit the tail. Your spars will be much longer than the ones here in the video. I made these short thinking they would be enough, but I find when I've crashed the plane, having the spars all the way up to the nose keeps the nose from stopping. You'll want to use a knife and cut about 1/8 of an inch or so into the fuselage. Then, using goop, welders, or hot glue, embed some glue into the fuselage and then run the spars all the way from about an inch into the tail all the way up to the nose. A little bit of a curve is just fine here. If you intend to laminate this plane, now would be the time to do it before the tail is installed. However, I recommend that it's glued foam to foam rather than foam to laminate. The tail here is simply glued in. There is nothing really fancy about it. The other moving surface is used to make the rudder or vertical stabilizer. I find approximately 6.5 inches is the optimal height. Taking a straight edge, I'll make a straight mark across it to make 2 equal sections. Then I'm going to use the smaller piece to make the contour by which I will cut out to make sure it fits on the rudder. At the backside, I'm going to cut at a 45-degree angle. This allows the rudder to move and allows the elevator some clearance. A utility knife or a hobby knife is all that's required. However, I really recommend making sure the knife is nice and sharp so you don't tear the foam. The knife should drag through nice and easily. Once cut off, add a little bit of hot glue and glue it down, being sure that you allow the rudder and the elevator plenty of room to move. The elevator and rudder control horn are simply glued in place and squashed between 2 locking plates. Take a knife and cut a hole in the foam where you want to put your control horn. Slide a locking plate over the horn, then press it through the foam after adding a little bit of glue. Once through, flip it over, and then add a little bit of glue where you see the protrusion, then slide the locking plate down and in place. It is best to have the elevator run below the vertical stab rather than above it because you don't want it getting caught in the propeller. Install the rudder control horn on either side. It doesn't really matter because it's going to clear your elevator anyway. Add a little bit of glue, a locking plate, then press it through the foam, add a little bit of glue to the other side, and then slide the locking plate in place. Don't worry too much about the height here. It should be approximately the height of a typical servo because a servo is going to be mounted right in front of the tail and behind the propeller. The wing on the Spark is simply glued together. Add a good amount of glue to the bottom surface, but also be sure to add a little bit on the top parts. These will simply fold out of the way. The foam is very flexible, so don't be worried too much about breaking the foam. Fold them out of the way and then press them in place. This plane was designed to be for FPV. I'm just going to add the camera just behind the nose, making sure there's enough nose there to protect it in a crash. The rudder servo on this airplane is glued in place at approximately the middle of the tail section. You want to give yourself enough room to be sure that the spinning prop will not cut the servo wire in flight. A little bit of hot glue is all that's really needed to secure it, but just be sure you have enough room so that the spinning prop doesn't hit the servo or the wire. The elevator servo is then glued upside down on the other side of the fuselage. Again, I am just gluing this in place. Control rods are made from the two metal rods by simply bending a Z-bend on either end. Make a Z-bend with a pair of needle nose pliers and install it in your control horn. Then mark the location where you're going to make the other Z-bend that will attach to the control horn on the surface. Then you simply cut off the excess. Once installed, just slide the control horn over the servo and screw in place, and it should be just about right. The elevator control rod follows the same process. Make a Z-bend, install in the control horn, mark the other end where the control horn is on the surface, make another Z-bend, and then install it. Once these are installed, you'll want to take some care to secure the servo wires to the fuselage so that they don't get sucked into the spinning prop in flight. Battery, you can either cut a hole in the fuselage or do what I'm doing here and just use sticky back Velcro. This seems to work relatively well, and the battery will determine the center of gravity of the aircraft. Now you'll notice that this was the prototype and the spars don't run all the way up to the nose. I found out why I needed longer spars the hard way when I crashed and snapped it full throttle. And now you're ready for your first flights. I might be crazy, and as always, keep 'em flying.